Okay, so this is the first part of the review for 3.1 to 3.4 tests. All right, we're going to do all the condensing and the expanding ones now, and then I'll do all the solving ones tomorrow in the second part of the video. So at the beginning, if it says to condense or expand, like I told you guys, that's not like a multiple choice. You do what you want. This is already condensed. This is already put together, so we're going to pull it apart. When I see that multiplication, I should think addition. So when I pull this apart, this becomes log 5 plus log 3. You're going to be asked to expand or condense and then completely simplify. So at this point, you need to look and say, can I simplify this? What this says is log base 10 of 5 plus log base 10 of 3. What that question is saying is there a number? Can I say 10 to a certain power that gives me 5? No. Can I say 10 to a certain power that gives me 3? No. That's why this right here is fully simplified, what I have circled. If you can simplify, you're going to need to, and I have two examples where I'm going to show you that. But in the second example, all right, we look here, I see this, I think addition, and I see this, and I think coefficient. Exponents become coefficients. So I'm going to rewrite this as log 3 plus log 2 to the third power. If you want to skip this one step, you can. You don't have to do this. But I would then bring the 3 down in front. So my simplified version would be log 3 plus 3 log 2. And just check, can you multiply 10, because this is log base 10, can you multiply 10 by itself a certain amount of times and give you a 3 or a 2? No, that's not going to happen, so you guys are good. All right, if I look here, guys, remember our exponent rules. This 6 goes to both the numerator and the denominator. Somebody asked me in C period, well, can I bring this out in front? You can, but then you have to remember to distribute it back in. So if I were you, when I see an exponent that's outside of a parenthesis, I would distribute it first. So I would rewrite this as log 6 to the 6th over 5 to the 6th. And now I see two coefficients. Exponents are going to become coefficients, right? And then I see that is going to become subtraction. You don't have to write those things, but I think it's a good thing to kind of put through your mind so you guys can remember that. So when I pull this apart, it becomes log 6 to the 6th power minus log 5 to the 6th power. And I have to go one more step because my exponents become coefficients. So this fully expanded would be 6 log 6 minus 6 log 5. Questions about that? Everybody's okay? All right, same thing here. This 2 is on the outside. So this 2 goes to both the A and to the B. I see this multiplication, so I think addition. So I'm going to rewrite this as log A squared plus log B squared. Then my last step would be to bring my exponents to be coefficients. So 2 log A plus 2 log B. You're going to have 4 condensing and expanding, and these should go pretty quickly because you're going to have 8 solving ones. You guys are only going to have a certain amount of time, and you need to get your test done in that certain amount of time. So make sure that you are proficient at working through these. All right, my next one, I see an exponent. It's going to become a coefficient. And I see a division. That's going to become subtraction. So I rewrite this as log x minus log of y to the 5th. Bring that 5 out in front. So fully expanded, this becomes log base 10 of x minus 5 log base 10 of y. Questions? All right, look at 6. What's going on between x, y, and z in this problem?
They're being multiplied.
They're all being multiplied. Yeah, they're all being multiplied, correct. So when I see 3 things that are stuck together with multiplication, when I pull them apart, it's going to all become addition. So when I rewrite this, I'm going to say, okay, well, I have log x plus log base 10 of y plus log base 10 of z squared. And then I need to bring that 2 out in front here. So when I rewrite it, it's log base 10 of x. You don't have to write the 10. If you do, it's no big deal. Plus log base 10 of y. I'm just showing you both ways just in case you see it. Plus 2 log base 10 of z. And again, I'll post these answers later. I'll also post the video. Just make sure you guys have it. What am I doing here?
Adding.
Okay, I'm adding, but this is already pulled apart, so I need to do what with it?
Condense.
I need to condense. I got to go backwards. So the first thing I'm going to do is remind myself that anything that's out in front is going to become an exponent. And then I'm going to look and I'm going to say, okay, I have log 6, log 6, log 6. All right, perfect. All of them have the same log. So I'm going to rewrite this with 1 log base 6. And since I'm adding, this is going to become multiplication. And this is going to become multiplication. So you can literally just say x, y, z to the 6th. It's a lot less writing when you have to smush it back together. All right, I'm going to come down here. Again, this is all pulled apart, so we need to smush it back together. Since I'm adding in all of them, that means I'm just going to multiply everything. I see this 4 as an exponent. I'm going to push it back there. So all of my logs are the same. It's log base 3. And I'm going to say 12 times 7 times 5 to the 4th. If you guys wanted to simplify this a little bit, you could say log base 3, 84 to the 5 to the 4th power. If you'd like to simplify even more, multiply the whole thing together, that's fine. I'm fine either way. And we come here. Again, I see this is going to become an exponent. This should become an exponent. When I see this subtraction sign, I think division. So I'm going to say 1 big log 2. And this is going to become 3 to the 3rd over 7 to the 12th. If you would like to simplify that to 27 to whatever 7 to the 12th is, you're more than welcome to. If you want to do just 3 to the 3rd because it's 27 and leave 7 to the 12th, again, that's fine. Just want to make sure we understand the concepts here. This is already smushed together. What do I need to do?
Change to subtraction.
Okay, I'm gonna pull it apart. This is gonna become a coefficient. This is gonna become a coefficient, and this is going to become a subtraction problem. So I have log 7 of 2 to the 3rd minus log 7 of 5 squared. These become my coefficients. So I have 3 log 7 2 minus 2 log 7 of 5. And this is where we have to just make sure that you can't simplify anymore. Can I simplify this? Can I say 7 to a certain power gives me 2? No. Can I simplify this? Can I say 7 to a certain power gives me 5? No. So I know I am fully simplified here. I'll show you 2 examples where you can do that, where you're going to be expected to, because it's going to say to condense or expand and simplify. So if we move on down here to number 11, right? Simple, guys. 3's are going to become coefficients. Division becomes subtraction. So I'm going to rewrite this as log base 5 of a to the 3rd minus log base 5 of b to the 3rd. Some of you are going to say, can I skip this step? If I know that I'm going to put them out in front, absolutely. But just make sure that you don't forget anything when you skip steps. Make sure of it. Questions? Everybody's all right? Okay. All right, let's look at 12. I have my exponent outside of my parentheses, so let's distribute this first. This is going to be rewritten as log base 4, 12 to the 4th power times 7 to the what? What's 4 times 2? 8. A power raised to a power is going to give us 8. So now when I pull this apart, this is log base 4 of 12 to the 4th plus log base 4 of 7 to the 8th And my exponents become coefficients. So it's 4 log 4 of 12 plus 8 log 4 of 7. Now, guys, common mistake right here. This 4 log 4 does not cancel out. If it was log 4 of 4 to a power, that's one thing. But all that's saying is just 4 times whatever log 4 of 12 is. So then you look and you say, okay, well, can I simplify this part? 4 to a certain power will give me 12? No. 4 to a certain power gives me 7? No. So you guys are good to go right here. All right, I wrote down these two examples. On these next one, I wrote down these two examples to show you what I meant by that. Can you guys read what this first example says? I'm not sure how that, why that errant circle got in there, but it says 1/2 of log 6, 16, plus 3 log 6 of y. So if I was going to rewrite this, right, my coefficients become exponents. So the first thing I'm going to do is say log base 6 of 16 to the 1/2 plus log base 6 of y to the 3rd. Right? I can rewrite this as 1 log. I'm going to rewrite it as log base 6. How can I simplify or rewrite 16 to the 1/2?
4.
Yes, it's 4 because the square root, 1/2 is square root. So this 16 to the 1/2 actually becomes the number 4, and then I would times it by y to the 3rd because this becomes multiplication. You just want to simplify as much as you can. That's why I don't suggest you do everything in one step so you can see. If this is already, look, if I'm going to push this back together, this is going to go here, this is going to go here. So I would rewrite this as log 3, right, of 27 to the 2nd power. You guys agree? Or, you know what, let's do it this way. We can do it this way too. You get the same thing either way. But yeah, let's do it. Okay. Sorry, having a conversation. So log 3 of 27 to the 2nd power minus log 3. What's another way I can write x to the 1/4?
The 4th root of x.
The 4th root of x, okay? Now look right here. What is log 3 of 27? Can I say 3 to a certain power gives me 27?
Yeah, 3 to the 3rd.
3 to the 3rd. So this expression right here simplifies to the whole number 3. And then you still have this squared here. Minus log 3 to the 4th root, or the 4th root of x. So what this really looks like, guys, is what?
9 minus log 3 square root of x and 4 to index.
You can just write it like that. All I'm saying is check. When you get to these, like here, log 6 of 16, if there's a root, rewrite it. Don't skip steps because there's going to be little places you can simplify that you guys are going to miss, and I don't want you to miss them. So just make sure of that.